welcome everyone again in Ganakul Class 9 YouTube channel. So, thank you for watching the last video. We would like to continue the next video today. So, I am with chapter 1, matters in our surrounding. Okay, so first we will revise what we have studied yesterday, and then we'll proceed. Okay, so yesterday we have seen, in last class we have seen the definition of matter. Also we have seen examples of matter, correct? Also we have discussed about properties of particles of matter. There were three properties of particles of matter. One is particles of matter attract each other. Yes. Next, particles of matter continuously moving. They are continuously moving. Okay, they are continuously moving. And then next property is particles of matter has a space between them. Particles of matter has a space between them. Okay, so we have shown this with examples also. Okay, uh, now today we'll discuss about the topics. Like today's topic, you can see states of matter. Okay, what are the states of matter? We'll differentiate between the different states of matter. How we can change the states of matter. Okay, so let us start today's class. Okay, if you say states of matter, there are mainly three states. Okay, one is solid, other is liquid, and other is gaseous. Okay, so one is solid, liquid, and gaseous. Examples of solid we can give like this chalk, like brick, and you can think again other examples like chair, your bench, like your books. Okay, like iron nails, like utensils in the kitchen. uh, these are solids, I think these solid, what are the solids examples? Again, examples of liquid can be of milk, then water, then kerosene. These things, I think liquids. What are the liquids? A lot of examples, I think it is coming to your mind. And next one state of matter is gaseous. Examples are, you can say LPG. LPG is okay, it is liquefied petroleum gas, so I will not write this, afterwards I will write. Gases are oxygen, then nitrogen, okay, carbon dioxide. Okay, so some of the gases also I have given examples, and a lot of examples it is coming to your mind, I think. So now first of all we'll differentiate these three states. Okay, we'll differentiate these three states with a table, differentiating table. So I'm writing here solid, then partition liquid, then partition gaseous. Okay, so let us start with the definition of solid. Definition of solid, 1 number point. So first definition is matter having fixed shape and volume. Matters materials having fixed shape and volume will be called as solid. Clear? Examples, if I ask then, how it will be solid? This chalk is a solid because it has fixed shape and fixed volume. Okay. Now liquid matters having fixed volume but not fixed shape. Okay, like liquid. Okay, liquid water, you can say, that have fixed volume, like means 1 liter water if you take, then the volume will be 1 liter only. It cannot be increased, it is not decreased. Okay, it is 1 liter only. And but the shape it do not have, because if you are putting this in a jar, then it will take the shape of a jar, and if you are putting in a other container, okay, like bottle, okay, then it will take the shape of a bottle. So it do not have fixed shape. But we have fixed shape or no? Yes, we have fixed shape because we are solid, and liquid, they do not have fixed shape. This definition is clear, I think. Next, gaseous states are the matter having no fixed shape or fixed volume. Okay, so gases is an interesting matter, means you can say, because they do not have fixed shape and they do not have fixed volume. Okay, like for example, if you take for example 1 liter of gases, it can be filled up in a tight container, okay, like cylinder, okay, and that gases can be filled up in the whole room, correct or not? So it do not have fixed volume. Okay, also it will take the shape of the container where it is kept, correct? So they do not have fixed shape and fixed volume. This is the 1 number point. Differences I have given about solid, liquid and gases. 2 number point is, you can say, solid and rigid. Rigid means they are tight. Okay, rigid. Okay. Oh, rigid. Solids are rigid. Okay, but liquid are not rigid. They are soft. Yes or no? And gases are again softer. Softer from liquid. Okay. Next point is the particles are tightly packed. Here there is a small gaps, or you can say spaces between the particles. Okay, uh, little, you can say, little space between particles. Okay, as it has little space between the particles, and that's why if you uh, dissolve other substances, okay, it will be mixed, because the particles will be filled up in the gaps or the space, okay, in the liquid. Now if you go for the gases, they have more space between the particles. In gases, we have already seen that the particles are apart from each other, okay, and there are more space between the particles. Okay. Then 4 number point is, particles are moving with a small distance, with small distance. Here you see, in solid also particles are there. We have seen that particles are moving, yes or no? But movement in the solid is less. Okay, they are moving, but there is no space pressure. They are moving in a less speed. But here means more than a solid. Movement of particle is particle is more than solid. Why? Because here space is little more than the solid. Okay. Next, in gaseous, the movement of particle is highest. Movement of particles is highest. Okay. So 4 points I have given. There are other points also. Okay. So at the last of the chapter of this chapter, okay, I will give you all the notes, okay, of the of this chapter in the description. Okay, so you can go through that because some points can be left while teaching. Okay, that's why you go for the description at the last end of this chapter. Okay, so these are some of the differences between solid, liquid and gases. Okay. Next point we are discussing is how to convert states, one state from other state. How we can convert, that means how we can convert a solid to liquid, okay, or a liquid to gases, or vice versa. That means from gas to solid liquid and liquid to solid. Understood? So if you go for conversion, I think you have little knowledge. For example, we have done experiment with the water. Okay, water, you know, it is found in what state? Liquid or solid? Liquid state, yes or no? But the liquid state can be converted into solid state. That is ice, we say. How? By freezing, by putting the water in fridge. Correct or no? And again, that liquid water can be converted into gases by boiling, yes or no? If you boil, then it will become steam, and that is vapor, or it is gaseous state. Correct? So if you see that, then there is one way we have noticed here, that is by using temperature. Using temperature. By using temperature, the topic is how to convert a state of a metal. Now, how to convert state of a matter? One is by using temperature. Okay. No, we have seen that by using temperature we can convert. Okay. One more way is there to convert the state of a matter, that is by using pressure. So we'll go in details to explain these things. Okay, using temperature, then using pressure. Okay. Let us see this. First one point it is. Okay. Let us consider solid is there, and liquid and gaseous. I am writing like this. So solid can be converted to liquid. How? By giving heat. Yes or no? So you know that ice will be converted to liquid water by giving heat. Okay. And also liquid can be converted to gases also by giving heat. Like we have, you boil the water, then it will be converted to gaseous vapor. Yes, water vapor. Okay. So by giving heat, we can convert from solid to liquid and liquid from gases. Okay. Now the point is that how we can convert gases to liquid and liquid to solid. Okay. Gases can be converted to liquid by, tell. Gases can be converted to liquid by cooling. Yes or no? Cooling. And the liquid can be converted to solid by also cooling. Understood? Clear or not clear this point? So a solid can be converted to liquid by heating up. Okay. Again, liquid can be converted to gases by again heat if you give. Okay. So in this way we can convert states of a matter by using heat. Okay, or by using temperature. Understood? The next process is by using pressure. Okay. So we have discussed about how we can convert uh, the state of a matter or by using temperature. Okay, now we'll discuss how we can convert the state of a matter by using pressure. Okay, so I have drawn a diagram. Okay, this is the diagram. You can see there's a liquid written here, solid written here, and gases written here. Okay, and arrows are given to show how we what what is the name of the process by which you can convert from one state to other. Okay, let us see. Liquid to gas, if you convert, that is by vaporization. Okay, this process will be called as vaporization. Okay, liquid to gaseous. And if you convert from gaseous to liquid, then the process will be called as condensation. Condensation process. Okay. Again, if you convert from solid to gaseous, the process name is sublimation. And if you convert from gaseous to solid, that process is also sublimation. Okay. Means if you go from solid to gases, the process is sublimation, and gases to solid, directly to solid, is also sublimation. Okay. Again, if you go for solid to liquid, then the process is fusion. Okay. And liquid to solid will be called as solidification process. Okay. Okay. Understanding these points. So there is one example. Okay. By pictures, I would like to show you how by using pressure we can convert one state to other state. Okay, that means from solid to liquid, liquid from gas. Okay, let us see. This particle, this is a syringe. Okay, this is a syringe, and this is the piston, and it is locked from this side. Okay, and there is some gases here inside. Okay, so these are the gases particles. Okay, I have drawn. Now see, these gases are here apart from each other. Okay, means distance is more. So here the syringe, the gaseous particles are in what's it? Gaseous state. Gaseous in state. Okay. Now if you pressurize, if you give pressure, okay, and this is locked here, then the particles of gases will come near to each other. Correct or not? The particles of gases will come near to each other, and this will become, as the particles are coming near to each other, it will become liquid. Liquid. Okay. And if you give pressure, okay, then particles of matter will come again near to each other, very means close to each other, and it will become a solid. Correct? So in this way, by using pressure, we can convert the states of matter. Okay, now I can see, if you remove the pressure, then the solid will be converted to liquid. Again, if you remove the pressure, then it will be converted to gases. Clear? So by using or decreasing pressure, we can convert the state of a matter. And now if we go for real life examples, there are different gases which is converted already from one state to other state. Let us take an example like LPG gas. LPG, have you heard? It is liquefied petroleum gases. That is, we are using in our kitchen. Okay, so this is a gas. See nicely, liquefied petroleum gas. It is a gas. Okay, and it is what gas? It is petroleum gas. Okay, and that is liquefied. Liquefied means by using pressure. Okay, by using pressure, the gases is converted or put in a cylinder, and in cylinder the gases is in the form of liquid. Understanding or not understanding? at this point. Okay, by using pressure, the gas, LPG gas, that is the petroleum gas, is converted into liquid. Okay, and therefore, other example like CNG gas, I think this I have heard it is using in the vehicles. Okay, there also that is liquefied gas is inserted in a cylinder and that is used for running vehicles. Okay, so in this way, by using pressure, we can change the state of a matter. Now we will discuss some of the definitions. Okay, so let us start. First, start with the boiling point. Okay, boiling point. So the temperature at which a liquid changes to gases. A liquid, for example, water, when you boil and the liquid water will be changed to gases, that temperature will be called as the boiling point. But you should mind that the pressure should be the normal. Okay, pressure should not be increased. Okay, therefore I have written state at 1 atmospheric pressure is called boiling point. Okay, understanding? Like example, I can give boiling point of water is how much? 100 degrees Celsius. Okay, that means at 100 degrees Celsius, okay, the liquid water will be converted to gases. Clear? Next, melting point. The temperature at which a solid changes to liquid. At 1 atmospheric pressure, ATP means atmospheric pressure is called melting point. So, for example, so the ice will be melted when if you give heat. Okay, so how much heat you need so that the ice will be converted to liquid, and that will be called as melting point of ice. And this melting point of ice is 0 degree Celsius. That means at 0 degree Celsius ice will be converted to liquid. Okay, next, freezing point. The temperature at which a liquid changes to solid. Okay, at 1 atmospheric pressure will be called as freezing point. Okay, freezing point means freeze from it is coming. Freeze means to become solidified. Okay, so freezing point means the temperature at which, okay, a liquid will be converted to solid. Understood? So what temperature is needed to convert a liquid to solid will be called as the freezing point. Okay, pause. Okay friends, so with this I would like to conclude today's class. Okay, so one more important things I would like to discuss, that you watch the video, okay, nicely. Then if you have got any doubt, okay, so you can contact me in WhatsApp. Okay, understood? I have made a WhatsApp group, Gyanakul class 9. Okay, there you can contact me. Any problems are there, I will take that problems and try to solve those problems in the next class. Okay, I am uploading every day. Okay, from Monday to Saturday. Okay, so any doubt you have got, I will try to rectify the doubts. Okay, and please try always means you have to subscribe it. Okay, down there red color button is there, subscribe button, there you press and keep the bell icon pressed. Okay, because whenever I will give the upload the video, no, you will get a notification and you can watch. Okay, so at last I would like to say that you stay at home, learn from home. Okay, and uh, in this pandemic stage, you take care of yourself. Thank you.